So there are two big beliefs that surround current resistance exercise guidelines. The first of those is that repetition load, or the amount of weight you lift per repetition, determines gains in muscle mass and strength. What I'm showing you here is a combination of the American College of Sports Medicine and the National Strength and Conditioning Association. What they say is that if you want to increase your muscle mass, you should lift between about 6 to 12 repetitions with a relatively heavy weight. If you want to increase your muscle strength, you should lift with probably fewer repetitions, but with a relatively heavier weight. But if you lift with a relatively light weight for greater than 15 repetitions, you won't increase muscle mass or strength, but you will increase muscular endurance. So data from our laboratory has directly challenged this. The main difference between what we are doing and the studies that make up those guidelines I just presented is that we have our participants perform exercise until volitional failure. So this is a study by Nick Bird in 2010. It's myofibrillar fractional synthetic rate on the y-axis there. In the open bars, you have a light lifting group, and in the dark bars, you have a relatively heavy lifting group. You can clearly see that 4 hours post-exercise, the acute anabolic response is the same between groups, so repetition load did not determine the acute anabolism anyway. It's actually the light lifting group that still has elevated fractional synthetic rate 24 hours post-exercise. Ken Mitchell followed that study up in 2012. He measured quadriceps volume via MRI pre and post 10 weeks of training with a relatively light and a relatively heavy load. And as you can see there, that's the percent change. There's clearly no difference between groups. The critique of this work was that it was done in a unilateral within subject design. It used an untrained group of guys, and it just looked at the knee extensors. Belief number two is that the post-exercise rise in certain systemic hormones also determines gains in muscle mass and strength. What I'm showing you here is a graph from the study I'm about to present. The point being, I have testosterone on the y-axis, but I could have put up growth hormone, insulin-like growth factor, or a variety of other hormones. The point is that following exercise, there's an acute rise systemically in these hormones that returns to baseline at about 60 minutes. So sports scientists and researchers alike use this post-exercise rise in systemic hormones as a primary outcome to determine the efficacy and efficacy of their training program or research intervention. That primarily comes from one review article. It's written by Kramer and Radamus in 2005. I could have pulled a variety of quotes from that review paper, but I'm just going to read out a couple for you. Number one there is that resistance exercise and/or training elicits a milieu of acute physiological responses that are critical for increasing muscular strength, power, hypertrophy, and local muscular endurance. He then goes on to write, resistance exercise elicits a milieu of hormonal responses, again, critical to acute muscular force and power production, as well as subsequent tissue growth and remodeling. Again, data from our laboratory directly challenges this. This is from Dan West in 2009. He's comparing a group exercising in a high hormonal condition and a group exercising in a low hormonal condition. It's myofibrillar fractional synthetic rate on the y-axis again. You can clearly see that there's no difference between groups. He followed up his own study over a period of 15 weeks. On the y-axis there, elbow flexor cross-sectional area. Again, a high hormone and low hormone group. And again, no difference in cross-sectional area. Thank you. Same criticism. Unilateral within subject design, untrained population, and it just looked at the elbow flexors this time. So the critique of those two programs of work were, number one, that they were done in a unilateral design, either comparing the right leg to left leg or right arm to left arm, and there could have been a cross-limb education effect. They were done in an untrained population, so if we were to give those guys any sort of resistance exercise, they were going to respond, and it may not be specific to the specific stimuli that we gave. And then lastly, they were done in isolated muscle groups, just the knee extensors or just the elbow flexors. So the present study, we used a between groups design We used resistance-trained men, and we had them perform whole-body resistance exercise. We did that to answer, does repetition load or the acute post-exercise rise in anabolic hormones determine mass or strength gains in resistance-trained men performing whole-body resistance exercise? To do that, we recruited 49 resistance-trained men and divided them into two groups. On the left there, that's the high repetition group. They performed about 20 to 25 repetitions per set and therefore lifted relatively light. The low repetition group lifted between 8 to 12 repetitions per set and therefore lifted relatively heavy. As you can see, there's no differences pre-training between groups. To give you an idea of how trained these guys were, you can see the numbers there, but the average training age going into this study was about 4 years. The study design was quite simple. We had them come in 4 times per week for 12 weeks. They had periodic strength testing or 1RM testing every 3 weeks. Pre and post training, they had a biopsy, a DEXA, and an acute blood time trial. So on that day, what it looked like is they came in, they got a biopsy, a catheter inserted, blood drawn, they exercised, and then blood was sequentially drawn 60 minutes following exercise. Okay, to orient you to these graphs, we have the high repetition group in the gray bar, the low repetition group in the open bar. We have interquartile range with the cross indicating the mean, line median, and the bars on either side as the min and max values. I'm showing you pre and post, and this has lean body mass on the y-axis. You can see there that there's an increase following 12 weeks of resistance training, but there's clearly no difference between groups. And it's the same story for both type 1 and type 2 cross-sectional area. Increase following training with no difference between groups. Here is the leg press and knee extension 1RM scores. And it's the same story. Increase following training, no difference between groups. Same story for both bench press and shoulder press. However, bench press had a significant group by time effect such that the low repetition group, or the group that lifted relatively heavier, increased their 1RM bench press scores more so than their higher repetition counterparts. Okay. We measured a ton of hormones. I'm showing you here free testosterone and the correlations with the change in muscle mass and strength. So this is the post-exercise area under the curve for free testosterone on the y-axis. You can see there with the change in leg press and bench press, there are clearly no correlations. On the far left there with the change in lean body mass, in the middle, change in type 2 cross-sectional area. And just to give you an idea, on the far right there, we had those 2 acute blood time trials, pre and post training, and I'm showing you that graph just so you can see that with training, there's no attenuation or increase in this post-exercise rise. So clearly no correlation. To give you an idea of some other hormones that we measured, I have testosterone, free testosterone, dihydrotestosterone, insulin-like growth factor 1, free IGF-1, growth hormone, and cortisol up here. This is just to give you a global snapshot of what we're looking at. On the on the length axis there is the change in muscle mass and strength. And the point being is that there are no significant correlations of any hormone at any time point with the change in any measure of muscle mass or strength. So the conclusion of my talk is the title of my talk, and that's that neither load nor systemic hormones determine resistance training-induced adaptations in trained men. We think there are 2 pretty big take-home points from this research. Number 1 is that we clearly need to revise current resistance exercise guidelines. The fact that we can lift lower loads to failure and not only maintain but increase skeletal muscle mass and strength may have direct implication in the applied sport and fitness setting. And this may also have implications in the aging and clinical population where they may not tolerate lifting relatively heavy loads. So providing them a practical alternative, lifting light loads, may be much preferred. With that, I'd like to thank the PhysSoc organizing committee. This study was co-ran by another PhD student in Dr. Phillips' lab. That was Sarah Oikawa. We had 2 undergraduate research students, Nicole Mazzara and Chris Wavel. We had an army of undergraduate placement students and research participants that I'd like to thank, as well as my supervisor, Dr. Stuart Phillips, and the rest of the protein metabolism research group. Thank you.
Thank you.